So just a reminder that we have journal test on Monday, and also the percent comp quiz. That'll be our last quiz. It's open notes. There's no re-quiz on that. And the review for your test, for your semester test, which is next week, the review will drop on today, actually later on today, so you can start working on it if you want to. We'll take the rest of Monday to do that after the journal test and the quiz, and then that's also what we'll be doing on Tuesday too. All right, so this is percent composition of just the nitrogen in iron 2 nitrate. And on the quiz, some are like this. It may just ask you for one element out of the compound. Some of them you may be given the compound. Some of them will be given the name, and then you'll have to write the compound. So the first thing is you got to write the compound for iron 2 nitrate. So what would that be?
17.4.
Okay, before we get there, Angel, I'm just going to start off just writing the formula. So what was your formula?
I used the calculator to calculate like how much nitrogen there was.
I know, but I'm asking you what was your formula for that compound, because you would have to have that correct to get the correct percent. Anybody have the formula for it? Nobody? Nobody in virtual either? That's amazing, since everybody did so well on their test yesterday. So I'm going to leave that for y'all to figure out. It's gotten where I do a journal, y'all sit around and just wait for me to do the answer, and I'm kind of really over that. So y'all need to figure that out. It'll definitely be on the journal test tomorrow, if you can't even give me the formula. All right. Oh, wait. I may be apologizing to somebody. Got me a chat here. Perfect. Jaheen, I owe you great apologies. I'm going to give you a +10 on your semester test or journal test. You can tell me which one you want next week, okay? That is what you would get for a Lowry loot if you were here in person. All right, so y'all are lucky. He got us going, and now we can finish it up. If I can get back into my connect in. All right, let's move forward. So we got at least the formula. So FeNO32. Once again, +2 -1. That's why I had to give my nitrate a 2. If you're still struggling with this, it's going to hurt you through most of next semester, because we continue to have to write formulas. So once we did that, you would have had to get the molar mass. And I'm not going to go all the way back through that because we've already done that before. But if you got the molar mass of the whole thing, I have it written down someplace. Molar mass of the whole thing was 179.87. We were just interested in the nitrogen, and we had 2 of them. So that was 28.02. And then multiply it by 100 to get it into the percent. 2 places past the decimal, just like we took our numbers off the periodic table. So 15.58%. And Angel, I'm sorry, I've already forgotten what you told me. So I can't tell you whether yours was right or not.
Oh, it was 17.4, but I actually miscalculated. Instead of adding the 2 in next to the parentheses, I added a 3.
Oh, okay. Which that would have worked, and there is an iron 3. So if that would have been a Roman numeral 3, then that one would have worked, right?
Oh yeah, that's right.
All right, so we're gonna do and this is in y'all's Chromebook. Y'all can decide whether y'all want to do it on paper or on the Chromebook. We're doing a virtual lab. We're looking, since we're dealing with percent composition, we're looking at the percent of water in a hydrate. So let me get over here to the right class. So under daily work, if y'all will look for Friday's virtual lab, and I'm going to pull it up in my drive. I think it's going to be easier for me. All right. Where did I put it at? Oh, maybe I don't have it in my drive. All right. So it should look like this. We've talked about hydrates before. There are ionic compounds because of their crystal lattice that they always have some water attached to them, and that's called a hydrate. So this, for instance, is copper 2 sulfate. The little dot doesn't mean multiplies, it just means it's a hydrate. And that copper 2 sulfate has some some water molecules that are in it. And to get rid of them, you have to heat them up to drive off of that water. So if I take that hydrate and I heat it up, then I end up with what's called an anhydrous salt. Anhydrous just means now it doesn't have the water in it. And then the water is left off, and usually it's just left off as steam. So we know that we get all kinds of medicines and other things that have those little gel packets in them. And that's because they are the anhydrous salt. So then they can accept some water and go back to being a hydrate. So they do the reverse thing, and that's there to figure out, to keep things fresh. So I'm going to give you just a couple of minutes and let you read over those first few paragraphs. And then we'll continue on. All right, so that's what we're going to be doing. If you come down here a little bit farther on the second equation, copper sulfate, the hydrate, is blue, a real pretty color of blue. When you heat it up, and we'll see in a minute on a YouTube video, they're going to just do with a Bunsen burner. It goes from blue to being white. And then that's whenever you know that it has gone from having the water to not having the water. So we'll see that that's when he will stop doing the experiment. If you were really here and we could do this experiment, that would be your sign to quit heating it up. So this formula right here, you're going to need in a little bit. To find the percent water, you would take the mass of the water divided by the mass of the hydrate. So you're going to have to be finding some molar masses in a little bit. And then multiply it by 100 like we do our percent composition. Does anybody have any idea how you think that we're going to find the mass of the water?
Just like what we do with any other formula, like gather up like the atomic mass for each atom.
Yes, right. You're right to find the molar mass, but I'm sorry I didn't make that clear. Like in the experiment, how do you think that we're going to know what the mass of the water is? Because we can't see it.
Let's see.
Yes, Roddy, what you got?
I remember the mass of the material before we enact the experiment, so that after it, we measure it again, and we subtract the two masses, and then what we're left with is the mass of the water.
That's perfect. That's perfect. Exactly. So what Rodney said is that you'll see the guy will get a mass at the beginning, and then he'll heat it up until it changes color, and that'll be driving off the water. So we'll get a mass at the end, and then you'll just subtract your larger minus your smaller, and then that'll be the assumption that that was all water that was driven off. So that's kind of the idea behind this lab. So after all, you'll need to use this percent water formula. So we're going to see him do the procedure, but that's what Rodney said is pretty much what he's going to do. You need to record these things as he tells you what they are. So he'll be giving you measurements. He'll tell you what the mass of a crucible is. A crucible is just, you're going to see it's a little porcelain dish that can be heated up. And then he'll tell you what the mass of the crucible is plus the hydrate. So to get the initial mass of hydrate, you would just subtract out your crucible. And then he'll do a second measurement with the crucible, but now it would have driven off all the water. So now it has the anhydrous salt. So then you'll do the same thing, subtract here. And then finally, to get the water of the hydrate, you're going to take your hydrate minus how much the salt is, and that difference is what will go here. On number 1, where it says determine the average mass of water, it's not an average. We're just going to do one trial. So you won't have an average, you'll just have a mass. So number 1 is actually the same answer that you'll have right here in your data table. So those will be duplicate answers. All right, let me get the video going. Oh, I forgot this was an active. And well, like I said,
let's go ahead and get started. We're in the laboratory today.
when he masses something and he says what that measurement is, then be sure that write that down, okay?
We're in the laboratory called the percentage of water.
I feel like I need to turn it up a little bit, guys. Hold on one second. I'm going to try to turn it up a little bit. Maybe it's just me that's having trouble here.
Hydrate. So I guess a good place to start would be to ask the question, what is a
Is
hydrate?
that loud enough?
Well, a hydrate, in this case, the one we're going to be using today is called copper 2-sulfate pentahydrate. This is a beautiful blue crystal, and as you can see, it's a very deep blue color. And it
Virtual, can y'all hear okay? If somebody will, thank you.
contains water. In
Oh,
fact,
man, I can
Copper
read it here.
2-sulfate pentahydrate contains 5 molecules of water. And so it's going to be our job today to experimentally determine the percentage of water in a hydrate. We did this in the lecture in our notes, but what we want to do today is compare what we've got in our notes to what we're going to get experimentally to look for any kind of error that may have occurred between what we calculated and what we actually do in the laboratory. The first thing we're going to do is we're going to get a measurement or get a mass of a crucible. A crucible is just a small vessel, a ceramic vessel just like that. It's able to withstand a large amount of heat. We're going to be heating up the copper 2-sulfate pentahydrate. Now I'm just going to place it onto the scale. I think we should balance the scale. The scale, by the way, should be measured up to a 1/100th of a gram. In this case, I get 12.51 grams. So I'll record that 12.51 grams as the mass of my crucible. The next thing I'm going to do is I'm going to place a small amount of the copper 2-sulfate pentahydrate onto into the vessel, the crucible. I'm not going to use that piece. I want to use a much smaller piece because it'll be a lot quicker and I'll be able to get a measurement a lot faster. So what I'm going to do is place a small piece of copper 2-sulfate pentahydrate into the crucible and I'll measure once again. This time I get 12.70. So 12.70 grams for the mass of the crystal and the crucible before heating. The next thing I need to do is set up the apparatus for heating. The ring stand is already set up for me. In this case, I've got a ring clamp. All I need to do now is to add a clay triangle. So clay triangle will just prevent or allow the heating of the crucible to take place and it'll provide a platform that I can place the crucible onto. So just make sure that it's steady, it's stable, and there's nothing that's going to move around during the experiment. So, by the way, the ring stand or the ring clamp should be about 2 or 3 inches, 3.5 inches at the most, away from the exit from the flame of the Bunsen burner. There shouldn't be any obstructions. Everything should be out of the way as you start the flame. Make sure that as you approach the apparatus, that the Bunsen burner or the lever is at a 45-degree angle, indicating that no gas leak is occurring. There's no impediments to gas flow in the tube itself, and that we should have a good flow of gas into the Bunsen burner. So we'll just take a match and start our Bunsen burner. Remember, when you light the Bunsen burner, you always start the match first, just like that. Now I'm going to make a C with my body, just like that. I want to maximize the distance between the match or the flame and myself, and then I'm going to, with my opposing hand, just start the flame just like that. Just slowly start the flame, and it catches pretty quickly, just like that. I don't need a terribly hot flame, so I'll back the flame up quite a bit. That's fine. That's more than enough right there. So the next thing I'm going to do is I'm going to start the warming of the copper 2 sulfide pentahydrate. Be very careful because of the fact that there's quite a bit of heat being generated by that flame. So you want to make sure that you respect the amount of heat that ceramic vessel, that crucible is able to absorb. So don't pick it up with your fingers by any means. It may not look hot, but believe me, it's going to get hot in just a few minutes. So the next thing is just the weight. It'll take just a few minutes for my little copper 2 sulfate pentahydrate crystal to desiccate, or the water to leave the crystal. So you'll see some noticeable changes, and I'll show them to you on the video in just a moment. But for right now, I think the best thing to do is simply wait and just give it a few minutes, allow the copper 2 sulfate pentahydrate to lose its water in the heat. I'll just turn it up just a bit, just like that. There we go. And as I do that, I hear a little bit of sizzling, and I see some changes. You can't see this, but I will just tell you that the copper 2 sulfate pentahydrate is losing that beautiful blue color, and it's just turning white. And I just use my glass stirring rod just to move it around just a little bit so that it doesn't get caught in one place. Okay? So there's going to be quite a bit of waiting in this laboratory, both waiting to heat it up and also waiting for it to cool down, because you want to make sure that it's cool before you place the crucible back onto the wave station for the balance. So it's really starting to get white now. I'll show you that again in just a little while. And see it's starting to crumble. I'll just do that just a little bit. And it's really starting to fall apart. It's not going to take much longer. If you use a small enough crystal, it shouldn't take more than 2 or 3 minutes. But you'll know that you're done when the crystal completely falls apart. It should look like almost like ash. Okay? It's really starting to fall apart. Be careful now. That flame is very hot. And I'll just give it a few more minutes. Okay, the key again is there's no real advantage to using a large crystal. So don't pick a large crystal out of the container that you're given. Try to find one that's not so large. You get the same exact results that you would have if you used a larger crystal without having to wait nearly as long. So this crystal that I have here is nearly completely disintegrated now. That blue color that we saw before is not completely gone, and I'll show you that now in the video. So I'll take it off the flame. I'm going to go ahead and turn the flame off now. There's no point in having it on while I'm waiting for it's cooling. I don't want to take a chance on getting injured or having someone be injured. But I hope you can see that on the video. The copper 2 sulfate pentahydrate, again, has
The black is not from the copper sulfate, okay? That black is just because probably it's obviously a used little container, okay?
lost that color, and it's now very much a white ash type of looking material. So I'm going to give that just a few minutes to cool down. Be careful about putting it on paper or any other surface that you don't want to burn, because it is very hot. Okay, so we'll give that a couple of minutes just to cool down. And while we're doing that, we're going to do a couple of calculations. One of the calculations that we want.
Okay, I'm going to jump ahead because he'll talk about some calculations, but they're not our calculations. Why was he using a glass stir rod? What's good about glass?
It has a low convection.
Yes, but that is not a very good conductor, right? So that he's not going to worry about becoming hot. All right, let me jump ahead to where. Should have written down what number where he was at, where he finally masked it out. Now he's going to mass it out, and then he talks about heating it up again. But then he doesn't give you a further number. So we're just going to go with the first number. But if you were in a laboratory, especially in a college setting, or if this was in a professional place where they were trying to drive off water, one time would not be enough. It would be repeated and seeing if the mass changed any. We're just going to go with it one time, I think. Let's see.
As you touch the crucible, see that this one, this crucible is pretty hot, and I'm just not sure that I would want that on the balance. So I'm gonna wait just a few minutes, okay, the percent error. So make sure you, okay. All right, I think that's just about ready to be moved over to the scale, and we'll get a second reading, okay? So this is the reading after heating. Okay, this is the amount of the mass of the pentahydrate after the heating. And what I get this time is 12.62. 12.62. So a bit lighter than before the heating. 12.62 grams. The next thing I'm going to want to do is I'm going to want to heat this a second time. I won't do it on video because it'll just take up that.
All right, so we're going to stop there with the video because you got your measurements that you needed. Let me get back to where I was at. Here, maybe here. All right, so you have your measurements that you need to complete the rest of your calculations. Down here where it's the bonus, if you're going to try the bonus and try to figure out what X is, you have to show your work on there. There's plenty of room for you to show your work. If you're using another piece of paper that to show your work here for these calculations, I think for y'all, if y'all want to, y'all just plenty of room on the back if you're using a paper. You don't pull another piece of paper. So if you're having to use another piece of paper to write down any calculations, please snap a picture of that and send it. But the bonus, the only way you're going to get that is if you do show some calculations. All right, so that's for y'all to fill out, to go through the rest of the process, and then be sure and turn it in. Like I said, water and the hydrate and number 1 should be the same answer. We do not have an average because we only did it one time. If you have any questions, then just unmute and ask them, and I'll see if I can help you out.